Hi, mathletes. Welcome to week 10, our final week of remote learning. We did it. We're going to finish up trigonometry this week. So we're going to take a look at how you can use trig to find missing angle measures in right triangles. There's only going to be one screencast. So I'm going to go through a bunch of examples today. And then after you finish watching it, you just want to practice, practice, practice. And then your benchmark, as usual, is due by 7 p.m. on Friday night. And if you have any questions, feel free, just send me an email. If you're having difficulty with the content, send me an email like as soon as you start to have trouble. Do not wait till Friday to email me and say that you're stuck. Email me early in the week and we can set something up. All right. So if you need to find an angle in a right triangle given the side lengths, you can use the inverse of that trig function. What you see listed here, these are the inverse trig functions. It looks like a -1 exponent, but it's really more notation. So this would read inverse tangent, inverse sine, inverse cosine. If you look on your calculator, you'll see that you have your buttons for sine, cosine, tangent. And then usually on the shadow on each of those keys, you'll see your inverse trig buttons. So to access those, you'd have to hit the second key, then sine, to get inverse sine, and so forth. I'm going to show you using the Desmos scientific calculator how you would find missing angles. So that's what we'll do here. I'm going to go through these 3 examples. So if you were trying to find what angle has a tangent value of 0.5, you would go to your calculator and you would enter in inverse tangent of 0.5. So if you were using this type of calculator, you'd have to hit second, tangent, and then 0.5. But let me show you using the Desmos scientific one how you would do it. On the main screen, you can see your regular sine, cosine, tangent. You have to hit function, and then that's how you can get your inverse trig functions to appear. So I want inverse tangent, and now you have to go back to the main screen to get the keypad. And so you would just enter in 0.5, and there you can see it's about 27 degrees, as you can see there. Let's try this next one. So inverse sine of 0.7314. If you're using this type of calculator, you would hit second, sine, and then 0.7314. If you're using the Desmos scientific calculator, let's try that out. I'm going to clear. I'm going to hit function, inverse sine, and I got to go back to the main screen, and I think it was 0.7314. I hope I'm right. I think that's it. And you get about 47 degrees. Yes. The last one, inverse cosine of 0.5592. So what angle has a cosine value of 0.5592? If you're using this model, you would type second, cosine, then 0.5592. If you're using the Desmos calculator, I'm going to clear it out. I'm going to go function, inverse cosine, go back to the main screen, 0.5592, and it's about 56 degrees. So that's how you would use the Desmos scientific calculator to figure those out. All right, so some fill in the blanks. So let's practice using your calculator. So all of these, cosine of what angle is about 0.0175? Sine of what angle is about 0.9659? So you're using your calculator to find the angle. To find the angles when you need to use the inverse trig function. So for number 1, what I'd like you to do is go to your calculator, whether you own one or whether you're using the Desmos scientific one, and enter in inverse cosine of 0.0175. And I'd like you to round to the nearest whole number, so the nearest degree. Try these 3 problems out. So why don't you pause the video and try these out, and then we can check to see if you got these correct. For number 1, if you entered in inverse cosine of 0.0175, it's about 89 degrees. For number 2, if you went to your calculator and typed in the inverse sine of 0.9659, it should be about 75 degrees. And for the last one, if you went to your calculator and did the inverse tangent of 0.2309, it should have come out to be about 13 degrees. Let's take a look at some right triangles where we have to find the missing acute angle. You're going to see a question mark where that's the angle that we're trying to find. The first thing that I'm going to do is label my sides. Where's the hypotenuse? Where is the side adjacent to this angle? Where's the side opposite to this angle? So that's still the same as before. We've been doing that for over a week now. And now in the next step, you've got to figure out what trig ratio are we using? Sine, cosine, and tangent. And now when you're trying to find a missing angle, it means that you must know two of the sides. What two sides do you know? Well, you know the adjacent and the hypotenuse. So what trig ratio uses the adjacent side and the hypotenuse side? If you said cosine, you are correct. So in our equation, we're going to be using cosine. We don't know the angle. That is our unknown. That's what we're trying to find. So you can either write cosine of question mark, but I like to use the Greek letter theta. And that's kind of more common. If you're going to take pre-calculus, you'll see the Greek letters a lot more. If you want to use x for the angle, you can also do that. So either question mark, theta, or an x would be okay. Cosine of the mystery angle, so cosine of theta, is equal to the adjacent side over the hypotenuse. Now, don't worry about simplifying. Yes, I really did just say that. You don't have to worry about simplifying because we're going to be using our calculator anyways. So whether you simplify this or not, it's all going to come out to be the same. If what you're trying to find is the angle, you're going to then take the inverse cosine of both sides. So notice how the only thing that changed is I just did the inverse cosine in front of both sides of that equation. On the left, these are opposite operations, so they're going to undo one another. And so the only thing that's going to be left is that mystery angle, which you're trying to find. And on the right-hand side, you're using your calculator. You're entering in the inverse cosine of 12 divided by 28. And to the nearest tenth, it comes out to be about 64.6 degrees. So make sure you're entering the inverse cosine and not just cosine. You use inverse when your goal is to find the angle. And in this example, we're trying to find the angle. Number 2, let's take a look at another example. I'm going to label the side lengths. So what was the hypotenuse? That's always across from the right angle. If I touch the angle, I'm touching the adjacent side, and then the only thing that's left is the opposite side. My goal is to find an angle. That means that I must know two of the sides. What two sides do you know? You knew the opposite and the hypotenuse. What trig ratio uses opposite and hypotenuse? If you said sine, you are correct. So when I set up my equation, I'm going to be using the sine function. However, I don't know the angle, so that's my unknown. Again, if you want to use a question mark, an x, or a theta, that's okay, but you need something to follow the trig word. So I'm going to do sine of theta equals the opposite or the hypotenuse side. If my goal is to find an angle, I'm going to have to take the inverse sine of both sides. On the left, these undo one another. So you are going to have that angle all by itself. And then you would go to your calculator and you would enter in inverse sine of 15 divided by 49. And you end up with about 17.8 degrees. Number 3, again, I'm going to start it off the same way. Here's the angle that I'm trying to find. I'm going to label the sides. What is the hypotenuse in this right triangle? What is the side adjacent to this angle that I'm trying to find? And what is the side opposite to the angle that I'm trying to find? Take a look at what two side lengths you know. You know the adjacent and you know the opposite side. What trig ratio uses the opposite and the adjacent? If you said tangent, you are correct. When you write your equation, you're going to be using tangent of your mystery angle set equal to the opposite over the adjacent side. Now, if your goal is to find this mystery angle, you're going to have to take the inverse tangent of both sides. On the left, these are going to undo one another because they're inverses. So you're going to be left with the angle, and then you go to your calculator and you'll enter in inverse tangent of 4 divided by 14, and you should end up with that angle is about 15.9 degrees. Let's close out today with a couple of word problems. If they don't give you a picture, then you want to make sure that you're comfortable sketching out the picture. Trigonometry is all about right triangles. So start with that. Sketch out a right triangle and then read each sentence carefully. We're working with a right triangle that has a leg of 1.5 units and the hypotenuse is 4 units. Find the measures of its acute angles to the nearest degree. So I decided that I'm going to find this angle. So I label my side lengths. So what was the hypotenuse side? What was the adjacent side to the angle that I am trying to find? And if I'm trying to find an angle, that means I must know 2 of the sides. So I know the adjacent and I know the hypotenuse. So I'm going to use cosine. Cosine of my mystery angle is equal to the adjacent over the hypotenuse. If I'm trying to find an angle, that's when I have to do the inverse cosine of both sides. So I'm going to go to my calculator. I'm going to enter in inverse cosine of 1.5 divided by 4. And I get about 68 degrees. This angle is about 68 degrees. I know that all 3 angles in a triangle have to add up to what? Right? It's 180. So that means that this other angle would have to be 22 degrees. Number 5, you are 200 feet from the base of a 100-foot tall building. Here's the building. You're 200 feet away. Here's where you are. What is the angle formed from the ground to where you are standing, from the ground where you are standing to the top of the building? Round to the nearest degree. So this is the angle that we're trying to find here. I'm going to label my side lengths. So where's the hypotenuse? Where's the adjacent side? Where's the opposite side to the angle that I'm trying to find? Now, if I'm trying to find an angle, that must mean that I know 2 sides. What 2 sides do you know? You know the opposite and the adjacent. That means you have to use tangent. Tangent of your angle is equal to the opposite over the adjacent side. If you're trying to find the angle, then that means that you're going to have to use inverse trig. So I'm going to take the inverse tangent of both sides. On the left, those operations are going to cancel each other out, and you're just left with theta. And on the right, what you'll do is you'll go to your calculator, you're going to enter in inverse tangent of 150 divided by 200, and then it is about 37 degrees. So this angle measures about 37 degrees. Okay, we'll do one last one. This is your last example for the year. Get excited. All right, number 6. A person stands at the window of a building so that his eyes are 12.6 meters above the level ground. So here's the person, they're in the building. An object is on the ground 58.5 meters away from the building on a line directly beneath the person. Compute the angle of depression of the line of sight to the object on the ground. So at the beginning of, I believe it was last week, I had you take notes on angle of elevation and angle of depression. Angle of depression is the angle from the horizontal measured downwards. So it is possible that you could solve this problem a couple of different ways. So this is all about right triangle. So here's my right triangle here. Here's the building height of where that person's eye level is. Here's how far away the object is. Angle of depression is the angle measured from the horizontal downwards. Well, this happens to be outside of the triangle that I'm working with. That's okay. Now, you might recall from earlier this year, we studied parallel lines cut by a transversal, and we have alternate interior angles. This angle that I'm being asked to find is going to be congruent to this angle because they're alternate interior angles. Now, that's one way that you can solve it. Another way that people solve it is they'll extend this out and they'll make a right triangle here, and they'll label this side as 58.5 and they'll label this side as 12.6. So that's another way that you could set it up. I am going to find this angle right here because I know it's going to be congruent to that alternate interior angle. And I'm going to label my side. So what was my hypotenuse and what was my adjacent side to the angle? And if my goal is to find an angle, that means that I must have been given two of the side lengths. What two side lengths were you given? You were given the opposite and the adjacent. So you think about what trig ratio incorporates opposite and adjacent. You said tangent, and you are correct. So tangent of your mystery angle is equal to the opposite side over the adjacent side. And to get the angle by itself, you take inverse tangent of both sides. So you go to your calculator and you're going to enter in inverse tangent of 12.6 divided by 58.5. And that angle is about 12 degrees. So this is a nice example to end with, a little bit of some throwback knowledge. And that is it. So this is the only screencast for the week. So we have a bunch of examples. So you might want to print out the notes. You might want to watch this again. There's a lot of different things. And there's absolutely tons of videos on YouTube if you want more examples. If you have any questions, send me an email. I hope you have a wonderful week, guys. Bye.